What is the application of differential equations? Also, what are general conic sections? Hello, it's Ms. Sujandra, and in this section, I am going to discuss the general basic concepts of application of differential equation in an engineering field and its specific problems. And afterwards, let's discuss about general conic sections, and we'll do problems too. So, straight away, with no delay, let's get into it. First, let's explore real worlds of applications of differential equations. Here, the differential equations have wide applications in various engineering and science disciplines. It is practically important for an engineer to be able to model physical problems using mathematical equations and then solve these equations so that the behavior of the systems concerned can be studied. So let's have a quick look in application to simple electrical circuit. Electric circuits may be regarded to be made up of an active element, that is, a source of energy such as battery or a generator. Three positive elements, that is resistance, inductance and capacitor. Let us discuss application to simple electrical circuit. Here voltage drop across resistance R is Ra. Voltage drop across resistance across inductance L is LdI by dt. Voltage drop across capacitance C is capital C equals to Q by small c. And in this application we will discuss about Kirchhoff's law, because the formulation of differential equation for an electrical circuit depends on the following Kirchhoff's law, and it has mentioned two rules. Number one is the algebraic sum of the voltage drop across any closed circuit is equal to the resultant electromotive force in the circuit, that is, voltage drop across resistance R and L is equal to the E, as mentioned in rule number 1, that is Ri plus Ldi by dt equals to K. As we have already discussed in above applications of electrical circuit, here it is given the voltage drop across inductance R and L is given, so it is and number 2 rule is the algebraic sum of current flowing into any node is 0. Here I have draw a picture of LR circuit which is in series connection. This is R resistance and this is L inductance, and this is EMF of a battery, and this is current, and these all are in series connection, so that the voltage drop across resistance R and L is equal to the specific problem of this application of differential equation. It is approach to electrical engineering, and in this question resistance and inductance is given and EMF of a battery is also given, and we need to have find current in the circuit as a function of time. So let's get into the solution. Here this is the solution of that question. Let us consider I be the current flowing in a circuit at any time t. Then by Kirchhoff's law, sum of voltage drop across R and L equals to E, as we have already discussed about it, so I don't think I have mentioned it. As you can see, this is the Ri is the voltage drop across resistance, and Ldi by dt is the voltage drop across inductance. So their algebraic sum of voltage drop across resistance R and inductance L equals to EMF of the battery. So to make it as a first order differential equation, let's divide both sides by L. So it looks like dy by dx plus py equals to k. So it will. So this is the equation, and this is the first order differential equations. So in this case, integrating factor will be e to the power p dt, and equals to e to the power integration of r by l dt equals to e r by l t. So its general solution is I into if, or integrating factor equals to integration of e by l into integrating factor of and its derivative with respect to t, and it is in the form of y into integrating factor equals to integration of q into integrating factor and derivative with respect to x. And by putting the value of integrating factor q and if here I into e to the power r t by l equals to integration of e by l into e to the power rt by l into dt. So again I into e, by solving this, I into e rt by l equals to integration of so this is the constant, so it comes outside of the integration. So so in this case rt e to the power rt by l as only integration, so it comes l by r and constant also comes. So therefore I equals to, by solving this, I equals to e by r plus constant into e to the power minus rt by l. So let us consider it as a equation 2. Here initially there is no current in the circuit. In the current, that is I equals to 0 when t equals to 0, because we need to have find the current as respect to function of time. So using I equals to 0 when t equals to 0 in equation 2, 0 in equation 2, I becomes 0 equals to e by r plus constant, that is constant equals to minus e to the e by r minus e by r. So equation 2 becomes I equals to e by r minus e by r into e to the power minus rt by l, or I equals to e by r 1 minus e to the power minus rt by l is the required solution. Now by putting the this shows that I increase with t and attains the maximum value e by r. Here in the question the value of resistance, inductance and the EMF of a battery is given. So putting the value of RL and E to the general solution, we come to this solution, and it is the required current in the circuit as a function of time. So this concludes my applications of differential equations part. Now let's discuss about general conic sections. First of all, let's discuss about some basic concepts of general conic section. It will be effective rather than directly jump into the problems. So here are some basic concepts of general conic sections. Here ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals to 0 is the general second degree equation, and it represents if a pair of lines, if determinant or delta equals to 0, and ellipse if ab minus h square equals to 0 and delta does not equals to 0, or parabola if ab minus h square equals to 0 and delta does not equals to 0, or hyperbola if ab minus h square is less than equals to 0 and delta does not equals to 0, and if a by h equals to h by b equals to g by f, then it represents two parallel lines. And a circle if a equals to b does not equals to 0 and h equals to 0, and it represents a circle. But this is in special case of an ellipse, and in special case of hyperbola, a rectangular hyperbola is represented if ab minus h square is less than 0 but delta does not equals to 0 and a plus b equals to 0. Among these, we will describe or discuss about parabola and ellipse. In this section we will not describe the hyperbola. We will describe it in another video or tutorial. So just remember this, the case of an ellipse and a parabola. So let's move into the another topic, where delta equals to matrix of ASG, SBF and GFC. This is a tip to memorize. First row and column is ASG, here ASG, and diagonal ABC, and remaining part right FF. In this way we can memorize trick to formula of delta. Note that an ellipse becomes a circle when major axis is equals to minor axis, and similar is the case of rectangular hyperbola. So these are the basic concepts of general conic section. Now let's solve the problem of parabola. Here is the question, and as parabola is mentioned here, we don't have to find the nature of the curve, as it is already mentioned, that is parabola, and this is in the general second degree equation. So we have to find the axis, tangent at vertex, equation, and length of lattice rectum, and coordinates of the vertex and focus of the parabola of this given equation. So let's check this solution. See, here is the solution of the given equations of parabola. As the nature of curve is already mentioned, that is parabola, we don't have to find the nature of the curve, as I already mentioned it. So the given parabola is 25x square minus 120xy plus 144y square minus 2x minus 29y minus 1 equals to 0, as it satisfies the condition, that is ab minus h square equals to 0 and delta does not equals to 0. As the given equation is in second degree equation, it represents a parabola as it satisfies this condition. So it is a parabola. Here is the equation of the parabola, that is 25. Here is the equations of a parabola: 25x square minus 130xy plus 144y square minus 2x minus 29y minus 1 equals to 0. And let's derive this equation in terms of whole square. So it becomes minus 5x minus 12y to the power whole square minus 2x minus 29y minus 1 equals to 0. And now introducing the lambda in the whole square, so it becomes the formula as a minus b plus c to the whole square. And now by applying the formula of a minus b plus c square, we get the solution like this, and by solving this we get the solution of equation 1. Here choosing lambda such that equation 2 and equation 3 become perpendicular. This is because in order to find the value of lambda, so 5x minus 12y plus lambda equals to 0 is the equation 2, and 2 bracket 1 plus 5x bracket multiplied by x plus 29 minus 24 lambda y plus lambda square plus 1 equals to 0 is the equation 3. So by evaluating the slope of 2, that is m1 equals to minus 5 by minus 12, which is the formula which comes by the formula of minus x by y, and its value is 5 by 12. And likewise we also find the slope of 3, m2 equals to minus 2 1 plus 5 5x 29 minus 24 lambda. And if 2 is perpendicular to 3, then m1 into m2 equals to 1. This is the case of the perpendicular. So if if 2 is perpendicular to 3, then m1 into m2 will become some minus 1. By putting the value of m1 and m2 in this, we get the value of lambda, that is equals to 1. Putting value of lambda in equation 1, that is here, this is the equation 1, 5x minus 12y plus lambda whole square equals to 2 1 plus 5 lambda into x plus 29 minus 24 lambda into y plus lambda square plus 1 is the equation 1. So by putting the value of lambda in equation 1, we get the solution like this: 5x minus 12y plus 1 whole square equals to 2 1 plus 5 into 1 into x plus 29 minus 24 into 1 multiplied by y equals to 1 square plus 1. And by solving this, we get the equations like this, which is in the form of Lx minus m plus n whole square equals to mx plus ly plus q. To convert it in the form of y square equals to 4x, that is standard form, we have to apply this steps to get a standard form. For this, first of all, multiply by root under L square plus bracket minus m square by both sides, and so that it becomes in the final like y square equals to 4ax. So this is the final equation of the equation 1, which is in the form of this expression. By applying the formula, we get the equations which is in standard form, that is y square equals to 4. That is, y is 5x minus 12y plus 1 by 13 is y, and 1 by 13 is the 4a, and this one is the x. Now as mentioned in question, we have to find different properties of the parabola, that is length of lattice rectum, axis of the parabola, equation to tangent at vertex, force directrix. So first of all, let us find the length of lattice rectum, which is whose value is 1 by 13, 1 by 13, or we can say 4a. By formula, it is 1 by root under L square plus m square. Now for axis of the parabola, that is y, as in this standard form, y is this, so 5x minus 12y plus 1 is y, which is the axis of the parabola, that is equals to 0. Now for the equation to tangent at vertex, it represents x of this standard form, and in this equation x is 12x plus 5y plus 2, so equation to tangent at vertex is 12x plus 5y plus 2 equals to 0. Now vertex equals to point of intersection of axis and tangent at vertex. Now we can find the point of intersection between axis and the tangent at vertex. Now solving these two, we can find by solving these two equations, we can find the vertex, that is minus 29 by 169 is the value of x, whereas value of y equals to 2 by 169. Use calculator, don't expand it directly. Now for the equation of lattice rectum, that is x equals to a, whereas 12x plus 5y plus 2 by 13 equals to 1 by 4 is into 13. It comes by the form of mx plus ly plus q by root under L square plus m square equals to 1 by 4 into 1 by root under L square plus m square, as I have already discussed about it. So by evaluating this equation, we get the solution. We get the equations 48x plus 20y plus 7 equals to 0, which is the equation of lattice rectum. Now focus. Focus is the point of intersection of axis and lattice rectum. By solving these two equation, point of intersection and equation and lattice rectum, we get the value of focus. We get the coordinates of focus, that is minus 2 by 13 and 1 by 52. With minus 2 by 13 is the points x and 1 by 52 is the y. So now finally equation to directrix is x equals to minus a, that is 48x plus 20y plus 9 equals to 0. So this concludes my parabola part. Now without any delay, let's move into the ellipse. So here is the equation of an ellipse, which is in second degree equation form, and I think it will not be effective if we do direct solution. So first of all, let's describe or discuss basic concepts of an ellipse, so that we can easily solve this specific problem of an ellipse. So here is the working rule of general ellipse, and I have divided all the process into step by step form. So here in step 1, first of all we have to identify the conic as an ellipse. There is are some process to determine a conic, so we will discuss it later. And then step 2, to find the center of the given equation, that is which is in the form of second degree equation, that is ax square plus 2xy plus by square plus 2gx plus 2fy plus c equals to 0. Let us consider it as equation 1. Then to find the center, differentiating 1 both sides partially with respect to 1, and let it be equation 2. And again, differentiating equation 1 both sides partially with respect to y, and let it be as 3. Then solving these two equation 2 and 3, with the we will find the value of center. Let it consider it as alpha and beta. Then in step 3, now we will shift the origin to alpha beta, that is x equals to capital X plus alpha and small y equals to capital Y plus beta, and the new equation will be ax square plus 2hxy plus by square equals to del by h square minus ab. And to make it as a 1 in RHS, multiply through by h throughout by h square minus ab by del, so that RHS will be 1. And compare the equation with ax square plus 2xy plus by square equals to 1. This is the value 1. Now we came to know a value of a, b and h. Here in step 4, to find the length of axis, use 1 by r to the power 4 minus 1 to the r to the power 2 or r square into a plus b plus ab minus h square equals to 0. And this is the quadratic equation. So using calculator, solve this as it takes much time, so direct use a calculator to solve this. So we will get a value of r. If the bigger answer is considered as r1, which is considered as semi-major axis, and the smaller answer or the smaller value will be r2, which is semi-minor axis. And in step 5, to find the equation of axis, that is equation of axis consists of major axis and minor axis. So for major axis, a minus 1 by r1 square, this is the bigger answer, the bigger value. So a minus 1 by r1 square into x plus hy equals to 0. And for minor axis, replace r1 with r2, so we can get the value of major axis and minor axis, and we can easily evaluate the equation of axis. But here note, don't forget to use small x equals to capital X plus alpha and small y equals to capital Y plus beta, and change it into small x and small y. In here at the time of evaluating the value, we must be very careful. So now in step 6, for eccentricity, to find the eccentricity, find using r2 square equals to r1 square bracket 1 minus e square, or also we can say it as b square equals to a square 1 minus e square. So this is the formula to find the eccentricity. And for latter spectrum, length equals to 2r2 square by r1, and we can also consider as 2b square by a. But we have to be careful, r1 is bigger value and r2 is smaller value, as we discuss here. So now let's move into another step. In step 7, write the equation of major axis refer step 5 means here in step 5, where is in step 5 here, to find the equation of axis we use this formula to find the equation of axis. So for this equation of major axis, we can easily find the equation of major axis. Now find the slope of major axis, that is tan theta equals to what? Generally we will determine the value of perpendicular base and hypotenuse, so that we can also find the value of sin theta and cos theta. As I discussed here, draw a right angle triangle and show find sin theta and cos theta. Here it is. So now for the first is alpha plus minus r1 eccentricity r1 cos theta comma beta plus minus eccentricity r1 sin theta, and by putting value of this we can find c. And for the equation of directives, it is x minus alpha cos theta plus y minus beta sin theta equals to plus minus r1 by e, and e stands for eccentricity. So this is the working rule of general ellipse. Let's move to the top. Here the question, as you can see, and first of all we have to find the conic represented by the equation given below. Here the equation is given 14x square minus 4xy plus 11y square minus 44x minus 58y plus 71 equals to 0, which is in the form of second degree equation, that is ax square plus 2bhxy plus by square plus 2gh plus 2fy plus c equals to 0. Now and here we have to find the center of an ellipse. Equation refer to the center, equation of axis and length of axis, eccentricity, length of lattice rectum, foci, and directrices. So without delay, let's get into the solution. Here this is the solution, and first of all here we have to find the curve. What does it represent? So first of all, here solution, here the given equation of a curve is 14x square minus 4xy plus 11y square minus 44x minus 58y plus 71 equals to 0, and comparing it with ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals to 0, which is the second degree equation. So by comparing we can find the value of a, h, b, g, f, and c. As we have find the value of this variable, by putting the value of variable in here, we find the value of delta, that is minus 9000, which is not equals to 0. Now again putting the value of a, b, and s, we find the value of a, b minus h square, which is 150 and greater than 0. Thus to become an ellipse it must satisfy this condition, so it is an ellipse. Now here to find the center, here given equation is 14x square minus 4xy plus 11y square minus 44x minus 58y plus 71 equals to 0, which is equation 1. Then differentiating 1 partially with respect to x, now which becomes 14 into 2x minus 4y into 1 plus 0 minus 44 into 1 minus 0 plus 0 equals to 0, that is 7x minus y equals to 11, which is equation 2. Now again differentiating 1 partially with respect to y, and by differentiating partially with respect to y we get the solution 2x minus 11y equals to minus 21, which is equation 3. Now solving these two equation 2 and these two equation 2 and 3, we get center, that is center C, that is 2 comma 3. Let us consider it as alpha and beta, as we have already discussed it about. Now to find the equation with respect to center, shifting the origin to center, we have small x equals to capital X plus 2 and y equals to capital Y plus 3, and by solving this, capital X equals to x minus 2 and y equals to small y minus 3. Let it be equation 2. Now also the new equation is ax square plus 2hxy plus by square equals to del by h square minus ab. Now to make it as a 1, we had multiply it by h square minus ab by del in the working rule, but here we have to put the value of the variable a as xy, so the equation becomes 7 by 30 x square minus 115 xy plus 11 by 60 y square equals to 1, which is let it be as a equation 3, which is the equation with respect to the center. And again, to find the length of axis, comparing 3 with ax square plus 2hxy plus by square equals to 1, we have this is the equation. So I have already in the working rule. So here by comparing 3 with this, we get the value a, h and b. Here a value of a is 7 by 30, whereas h equals to minus 1 by 30 and b equals to 11 by 60. To find the length of axis, use 1 by r to the power 4 minus 1 by r square into a plus b plus ab minus h square equals to 0. Solve this quadratic solving this quadratic equation using our calculator, because it takes too much time to express it to calculate the value. So now calculating this quadratic equation using calculator, we will find the value of r, that is 4, and that is r square equals to 4 and 6. Find the value of r, and it has two values, and as we discussed in the working rule, the two roots say r1 is the which has the bigger value will be semi major axis, and r2 which has small value is the semi minor axis. Now as you can see, length of semi major axis equals to root 6, and length of semi minor axis equals to 2. Now to find the equation of axis, first of all we have to find the major axis, that is by this formula a minus 1 by r1 square into x plus hy equals to 0. That is by putting the value of a r1 we will find the equation, that is 2x minus y equals to 0. As we have discussed in step 5 in working rule, capital X and Y must be changed in terms of small x and y, so it becomes like this. So 2x minus 2 minus y minus 3 equals to 0 by 2, and by solving this equation becomes 2x minus y equals to 1. Now likewise for the equation of minor axis is a minus 1 by r2 square x plus hy equals to 0. By putting the value of a, r2 and h, we find the equation like this: x plus 2y equals to 0. And as we discussed in previous section equation of major axis, that is we must express capital X and Y in terms of small x and y, so it will becomes x minus 2 plus 2 y minus 3 equals to 0. That by solving this, x plus 2y equals to 8. Now for the eccentricity and the length of lattice rectum, it is easy, so let's discuss it here. as we as we have already find the value of r1 and r2, r2 square equals to this is the equation, and this is a formula to find the eccentricity of an ellipse. So r2 square equals to r1 square into 1 minus e square. By putting the value of r2 r1 and r2 r1, so we will come to this step. 1 minus e square equals to 2 by 3, that is e square equals to 1 by 3, and we will come to the conclusion that is e equals to 1 by root 3. And for the length of lattice rectum, that is equals to 2 r2 square by r1, or we can also consider it as a 2b square by a. Now by putting the value of r2 and r1, we can also find the value of lattice rectum, that is 4 root under 2 by 3. The equation of major axis is 2x minus y equals to 1, which is in the form of ax plus by plus c equals to 0. Now finding the solve of major axis equals to minus 2 by minus 1 equals to 2. That is tan theta equals to 2 and tan theta equals to 2. We can also find the value of sin theta and cos theta by drawing a right angle triangle and then solving. Here this is the right angle triangle, and this is angle theta, and this is perpendicular to and the base 1, and h is calculated by using Pythagoras theorem, that is h square equals to p square plus b square. We can find the value of tan theta, that is 2 by 1 p by b, and so sin theta equals to p by s, that is 2 by root 5, and cos theta equals to b by s, that is equals to 1 by root 5. And the slope of major axis a by b, this will be ax plus by plus c equals to 0, that is minus a by b. Now for 4c, this is the formula to find the 4c, that is alpha plus minus eccentricity r1 cos theta, comma beta plus minus eccentricity r1 sin theta. And by putting the value of alpha, eccentricity r1 and cos theta and sin theta beta, we can find the value of 4c, that is 2 plus minus root under 2 by 5 comma 3 plus 2 root under 2 by root 5. And finally the equation of directrix is x minus alpha cos theta plus y minus beta sin theta equals to plus minus r1 by b. This is also the formula we have discussed earlier. So here by putting the value of alpha, theta, beta and r1 and eccentricity, we can also find the equation of directrix, that is x plus 2y equals to 8 plus minus 3 root 10 is the equation of directrix. This concludes my ellipse part.